Set is a well-defined collection of objects. It is denoted by a capital letter. There are three ways of writing sets. In this given, the set of natural numbers between 10 and 20. This way of writing is called word description. And this format, wherein it is read as n, is an elements containing, or n is the set of elements containing 11, 12, 13, 14, 15, 16, 17, 18, 19, wherein the elements are listed. It is called a roster notation or listing method. In this format, wherein it is read as set n is a set of all x such that x is as counting numbers between 10 and 20. So this form is called a set builder form or a rule method. When we say cardinality, it is the number of elements in a set. So if you are asked to find the cardinality of a given set, so let's say we have a given set C containing 1, 3, 5, 7, 9, just simply count all the elements. So in this case, 1, 2, 3, 4, 5. So there are 5 elements in this set. Therefore, the cardinality is 5. And it is written as n parenthesis 5. In given number 2, W is a set containing 0, 1, 2, and so on and so forth. So these 3 dots here, it means it is an ellipsis. It means it goes on forever. So therefore, our cardinality is infinite. Okay? So this symbol here is called a lemniscate. It is not a number, but an idea of a number that never ends. So this symbol here, it means null set or empty set. It is similar to this symbol, a curly bracket with no elements. So obviously, the cardinality is 0 because it does not contain any elements. If all elements of set A are also elements of set B, then we can say that set A is a part of set B, or set A is a subset of set B. So consider these 4 sets here. Notice that set B, the elements 2 and 4 can be found in set A. So we can say that since set B is a part of set A, we can say that set B is a subset of set A. Similarly, in set C, wherein it contains an elements 4 and 6 which can be found also in set A, we can say that set C is a subset of set A. While set D, although it contains 4 and 6 that can be found in the elements of set A, but it also contains an element which cannot be found in set A. Therefore, set D is not an element of set A. I mean, set D is not a subset of set A. So it is just a symbol of subset with a slash that denotes not, or not a subset. Now, if we want to determine the number of subsets in a given set, let's say we have a given set here that contains 2 elements, 4 and 6. How many subsets does it have? So let us write them. So one of its subsets is 4, 6, 4, 6, and the empty set. Empty set is a subset of every set. So if we're going to count all the subsets of this set, 1, 2, 3, 4, so that is the number of subsets. So what if a set has 3 elements? How many subsets does it have? Okay, let us write it down. One of its subsets is 4, then 5, 6, 4, 5, 5, 6, then 4, 6, and 4, 5, 6. Actually, the set is the subset of a set itself. Then the empty set, which is also considered as a subset of every set. So if we're going to count all of the subsets of set D, so that is 1, 2, 3, 4, 5, 6, 7, 8. So therefore, the subset is 8 if a set has 3 elements. What if it has 4 or more elements and we don't have the luxury of time to list down all the subsets? So we can use this expression. So the number of elements is expressed as 2 raised to n. So let us try to use this in our given set, set C, wherein it contains 2 elements. Since it has 2 elements, the cardinality is 2. So we will just replace that cardinality, which is 2, in our n. So it becomes 2 squared, and 2 squared is 4. Notice that they have the same answer. Okay, let us try that with a set of 3 elements. So write the expression 2 raised to n, then replace this n here, the number of elements, which is 3, or the cardinality, which is 3. Then 2 cubed, simplify, and that is 8, because 2 times 2 is 4, times 2 is 8.